we go through this. So starting with this first one, this is a half pi, so I should hopefully kind of realize a half pi is going to be on that unit circle. Okay? It's negative, so I'm going to go backwards. 1 half, 2 halves, 3 halves. So that is the point I'm looking at. We learned back in chapter 5 that cosine is the x value, sine is the y value, and tangent is sine over cosine. So I still should know those same concepts. So when I'm looking at this value on my unit circle, this is the point 0, negative 1, or sorry, 0, 1. So sine is the y value. The answer to this is 1. Okay? So I'm using my unit circle. I found out where I am on my unit circle. I took the trig function of that value, and it's decided by positive or negative by what the point is. So in that case, I don't have to worry about that. So now looking at this one. Tangent of 25 pi over 6. It's got a 6 on the bottom. So I'm using my 30-degree reference angle. Okay? So I already know, I'm going to write this down in a second, but if I'm using this as my angle, for tangent, I'd have 1 over the square root of 3. Which, of course, I have to simplify to the square root of 3 over 3. So I'm using which triangle? The one with the 6. That's pi over, pi over 6 always has a 30. Which trig function for tangent of that? So opposite over adjacent. And then I have to decide if it's positive or negative. Here is a trick to knowing where this is. Radians is always written as an improper fraction, but 25 over 6 is the same thing as 4 and 1/6. And that makes it easier to know where to go. Because on your unit circle, remember every pi is 180. So 1 pi, 2 pi, 3 pi, 4 pi, and now I want to go another 1/6 of that value. So 1/6 is here in this quadrant. So everything's positive here. My answer is a positive square root of 3 over 3. Now, the reverse of this. We also did this before. Now I'm looking for the angles. So I have to think backwards to this. So first of all, I have to know which triangle I'm going to be using. Square root of 2 over 2 is my 45, 45, 90, which has a 4. So I already know for my answers for alpha, and remember there's always 2 answers when you're finding the angle, I'm going to have pi over 4. I just don't know how many pi's over 4 I have. That's where the positive and negative come into play. So I need to know where is sine negative. Well, it's positive in the first and the second quadrant, so it has to be negative in the third and the fourth quadrant. So in the third and the fourth quadrant, let's start off with the third quadrant. I'm going to go 1 pi and another pi over 4. So that would be 5 pi over 4. Here's where knowing how to add fractions becomes really important. In the fourth quadrant, I would take the easy way of doing this and write a negative pi over 4. Okay? Your other option, all the way is 2 pi, but I'm not going pi over 4. So I need to take 2 minus a fourth, which is 8 over 4 minus 1/4 is 7/4. You cannot plug this whole thing in your calculator at once because the pi is going to automatically round it. So I need to know how to add those fractions without just plugging that number in my calculator. Now also in chapter 5 we talked about, these are part of our answers, but remember we added 360k? Well, I'm not going to add 360k because this is in radians. So what I am going to do is add the equivalent to 360 which is 2 pi. So I'm going to add 2 pi k, and I do need to label. You can label your radians just at the very end. You don't have to label it here and here. Okay, so that whole thing is in radians. Those are your first type of problems. Given the angle and finding the trig function, given the trig function and finding your angle. And this is why you really have to understand that stuff we did in chapter 5, because we're doing it again, but now in radians, something you're a little bit more unfamiliar with. Okay? The second part of this section is arc length and area of a sector. Both you did in geometry, minus the fact that you didn't always have it in radians. So in geometry, you looking at a ratio, and everything was always in 360. Keep in mind, if your angle is in radians, I can't use 360 degrees. I have to use the same type of measurement. So if my angle is in radians, it's going to be over 2 pi. If you still want to use a ratio, that works completely. So I'm comparing the central angle to the whole circle. I would be comparing the arc length to the whole circle, and the whole circle, that's called the circumference. Arc length is like finding part of your circumference, a portion of it, a fraction of it. This is one way you can do the problems. I actually prefer to do it this way because otherwise some people mess up when they're given the arc length. Okay, so if I'm going to solve the problem this way, here's the same formula. I just looked at cross multiplying and dividing by, and I wrote it in 2 pi. So if I'm given it in radians, I'm going to use the top one. If I'm given it in degrees, I would use the bottom one. Okay, so in degrees versus in radians. This is why it says part over total. Part over total just means your angle over what it's out of, either 360 or 2 pi. The area formula looks very similar. So now if I'm looking for the area of this, it looks very similar to this, except for instead of circumference, I'm going to use the area formula, pi r squared. So again, I'm finding a fraction of the area. What part over the total times pi r squared. So if it's in degrees, I'd have, like, for example, 60 over 360. If it's in radians, I'd have pi over 3 over 2 pi. And then area is the part that I'm finding. Sometimes you are just given a straightforward question. Like this one is asking me to find the arc length. So I'm going to go ahead and write the arc length is part over total times 2 pi r, like the circumference. I'm going to fill in what I have. I have the radius. So the 2 pi is just a number. I have the radius, which is 7. I have the central angle in radians. So when I go to do this problem, my part of my circle is 25 pi over 36. That's in radians. So this has to be in radians. If they're not in the same unit, then your radians wouldn't cancel and you would have some funky measurement. Radians divided by degrees times centimeters. That doesn't make any sense. These are going to cancel, so I'm going to be left with a length, centimeters. I'm going to be left with the question that I'm asked, my unknown, the arc. I expect these answers to be exact, or you will lose points. So you have to, again, do some math. Now, on this problem, there's a lot of things that can cancel. The 2 pi is on the bottom, it's being divided, and it's being multiplied, so I can cancel those two. So I'm really going to be taking 25 times pi times 7 and dividing it by 36. Now I left it this way on purpose because 36 doesn't go into any of these numbers. So when I go ahead and multiply 25 times 7, I know 175 pi over 36 cannot be simplified, and that would be my answer.